This is x-axis, this is y-axis, and third axis is perpendicular to this plane, and that we call it as z-axis. Suppose I have a vector in this plane, x or y plane. I call that vector to be a vector. So I can transform this vector. I can rotate this vector. For example, rotation is also one of the transformations. So orthogonal transformation. Suppose I rotate this vector, I can do rotation. So there are two possible transformations here. One is called active and another one is called passive. So there is active transformation, there is passive transformation. Active transformation means the vector itself rotated. The vector itself rotated. Coordinates are fixed. So the active transformations, vector is rotated, but coordinates are fixed. But in the passive case, vectors are fixed, vector is fixed, coordinates are, there is axis x, y, z are rotated. Okay. That means, suppose I'll start with passive case first, then we'll go to active. Suppose I am doing passive rotation. So what I am going to do? I am not going to rotate this vector. I am not going to rotate this vector. This vector is kept fixed. The axes are rotated. So the rotated axis I call ax prime, and this is x prime, and this is y prime, and this rotation is done on an angle phi or theta. Okay, so angle phi. So you can write a transformation equation.
That angle is also. I'm wondering whether you're rotating off the plane.
Rotation about the
z-axis.
Z-axis. So there is no rotation about z-axis. Okay. So therefore, this is kept fixed. Now one can write this in the matrix form, this transformation equation in the matrix form, where this is vector before transformation in the old coordinate, and this is vector in old coordinate system, and this is vector in new coordinate system. I'm going to write. This is ax, ay, az, and this is ax prime, ay prime, and az prime. So now what is the transformation matrix? Cos phi, sin phi, 0, minus sin phi, cos phi, 0, 0, 0, 1, because z-axis is not rotated. Rotation about z-axis. Therefore, you should write 1 here. This transformation can be written in the more compact form. That is, this is a prime, correct? Or this is prime axis, and this is unprimed axis, and this is a vector, and this is vector. Therefore, what it should be? Tensor, correct? Tensor of rank 2. So therefore, this is, suppose I can write this as Rij, this is I, this is G. This is an orthogonal matrix. This is a matrix. So this is an orthogonal matrix. Therefore, Rij into Rji transpose. This is equal to how much? Kronecker delta, which I am going to say. So Kronecker delta I. This is equal to 1. This is equal to identity matrix. I can put, instead of this, I can put K and then I can put delta I. I can put K and I can say this is delta I. And which index here is summed over? J is summed over. And when I is equal to K, that means only diagonal entries. For the identity matrix, the diagonal entries are 1. So I have used Kronecker delta for this.
Just a question. You write the equation. How do you decide whether the I and J is in the subscript or subscript? The previous equation. Is there any notation or you should write only the subscript?
You can write the superscript, but right now it's a transformation equation for a vector from one vector old to one extended new. This is a matrix form, okay, which is given in all textbook. In tensor way, this is a contravariant vector, this is a contravariant vector, you have to put that index and then the transformation equation, you will write Lxi by del, that transformation equation. But right now I am not motivating in that way, so I am going to do some problems based on this.